What lies beyond the star-studded blanket that covers our skies at night? Who or what is out there? Questions like these have plagued the hearts of people from time immemorial. Ancient stargazers were so named because of this very curiosity. Great astronomers like Carl Sagan, Stephen Hawking, and William Kenneth Hartmann have made amazing discoveries that have spurred even more curiosity. Yet, there remain mysteries that our planet's greatest geniuses have been unable to comprehend. Welcome to the Cosmic Drifters channel as we explore the mysteries of the universe. Before we get into these discoveries, don't forget to like and subscribe to our channel. Okay, now let's get into the discoveries we've found. We'll start with the concept of the dark duo, dark matter and dark energy. Dark matter constitutes about 27% of the total mass and energy content of our universe. Calling it dark seems to infer that it is black, but it actually is invisible. It's an entity that doesn't emit, absorb, or reflect light. Light simply goes through it, as if it was some completely transparent material. That just means we can't tell if it's there by merely looking. Light needs to interact with materials for us to see them. No light, no sight. That's why dark matter is invisible. It's like a ghost living in our universe. How do we know it exists, though? Because of its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. The phenomenon of dark matter was proposed when astronomers observed that stars move at mind-boggling speeds. Such speeds can only be attained if there is more matter than we can see. There's also the concept of gravitational lensing. Gravitational lensing occurs when light bends as it travels from distant galaxies through regions filled with dark matter. The gravitational field of dark matter causes the path of light to bend, allowing scientists to map the distribution of matter. We can't see it, but we know it's there. Dark energy is another mystery that takes up a huge chunk of our universe's mass energy content, up to 68%, actually. It was discovered in the late 1990s through the observation of distant Type 1a supernovae. Prior to this, it was revealed that the universe was expanding. Scientists expected this expansion to slow down over time as it would succumb to the force of gravity. However, the 1990s studies revealed that the opposite was the case. The rate of expansion was growing. Like one scientist explained, it's like throwing your keys in the air and expecting them to drop, except they don't. They continue to go up toward the sky against the force of gravity. This opposing force is what has been termed dark energy, and it is responsible for the expansion of the universe. You know what's scary? No one knows how this is happening or why. Of course, there are hypotheses, but that's all they are. No plausible explanations. No proof. Nothing. Another mystery of our massive universe are the Fermi bubbles. Nothing about that name spells mystery. In fact, it sounds like a cartoon character or some infant-related concept, but the truth could not be any farther. U.S. astronomers from the National Aeronautics and Space Administration, NASA, were observing our galaxy back in November 2010 using the organization's Fermi Gamma-ray Space Telescope when they made an interesting discovery. Right there at the center of our Milky Way galaxy were two bubbles composed entirely of gamma rays. Gamma rays are like the hotshots of the electromagnetic spectrum. They are the highest energy photons in the universe, with the ability to penetrate just about anything. These electromagnetic bad boys travel at the speed of light, damaging as much as they can along the way. In fact, they have been detected up there with the Sun, especially as cosmic rays enter the Sun's atmosphere. Thankfully, our planet's life-supporting atmosphere shields us from their effects. Most times, gamma rays that seem to come near us come from a long distance after events like a supernova or the explosion of a star. Yet, here we are with two giant structures emitting gamma rays right at the center of our galaxy. Here's what we know about the Fermi bubbles. They are enormous, sharp-edged, well-defined structures estimated to stretch for about 50,000 light-years in each direction. Positioned right above and below the galactic center, they have the form of an hourglass, or the number 8. One supernova is dangerous enough, But some scientists have said that the Fermi bubbles have the energy of about 100,000 exploding supernovae. We also know that they may only be a few million years old, but there's a lot more that we don't know. Where did these bubbles come from? No one knows. Because of their high energy, some scientists have suggested that they may be remnants of a burst of star formation. Others think this may only be one of the ingredients that produce the gamma-emitting balls. All in all, no one really knows. Yet, there they stand, another mystery of our universe. Now, let's talk about one mystery that's quite close to home, the Moon's magnetic field. We all know that, unlike the Earth, the Moon has no global magnetic field. That's why people always talk about a compass being useless up there. Maybe navigation would be great, but what else would be the point of a magnetic field for the Moon? Let's use Earth as an example. Our planet's strong magnetic field protects us from the harmful cosmic rays we just talked about. It's one of the life-supporting features of our dear planet, so it's possible that the Moon would be more habitable if it had this. That's why it was particularly intriguing to astronomers when they learned that the same celestial body seemed to generate an intense magnetic field up to about 3.56 billion years ago. If Earth's Moon had a magnetic field, is it possible that it may also have hosted some life forms? Explanations that were given in the past for the lack of a magnetic field on the Moon are its small size and solid core. Since the Moon is smaller, its core should cool and solidify faster. Why does this matter? Because of the dynamo effect, which essentially fuels the Earth's magnetic field. As the Earth's molten core moves, it generates electric currents through convection, and these currents in turn produce magnetic fields. No molten core, no convection, and without convection, there would be no magnetic fields. However, if new evidence says the Moon had a strong magnetic field years ago in spite of its solid core, how did it produce it? Another important question that puzzles scientists is how the celestial body lost its magnetic field. Could it happen to Earth? We hope not, but until we figure out the mystery of how the Moon lost its magnetic field, I guess we can only keep our fingers crossed. The next mystery we'll be looking into is the cosmological or primordial lithium problem. Here's the story. The Big Bang Theory is a widely accepted explanation for the origin of the universe. It says that everything that exists and has existed in the universe began at the same time, about 13.8 billion years ago. According to the Big Bang Theory, or BBT, as many people call it, there was a very small ball with infinite density and heat called the singularity. All matter as we know it was compacted in the singularity and began to inflate and stretch, producing the still expanding universe that we have today. Based on this theory, the universe was filled with the three lightest elements, hydrogen, helium, and lithium, right after its creation. Other elements are said to have come from stars. To support this claim, scientists calculated the abundance of the primordial light elements and compared it to what they've observed in old stars. The issue is that the amount of lithium observed doesn't match up with the calculations. In fact, these calculations show that there should be 3x as much lithium as we have right now. The cosmic lithium problem is especially intriguing because every other element checks out and supports the Big Bang Theory. So, where did the lithium go? As expected, scientists have tried to put forth theories to support this. One of them is that some stellar processes may have depleted and are still depleting the cosmic lithium stores. No one knows what these processes are, so it remains a mystery. This video about the mysteries of our universe would sure be incomplete if we don't talk about the probability of extraterrestrial life existing somewhere out there. We have too many movies about aliens from outer space invading Earth, and given the size of our universe, it's not surprising that many people wonder about it. Is this mystery worth considering logically, or are we just falling for the extreme imaginations of sci-fi writers? Well, science says it's not unfounded. NASA believes that there are billions of exoplanets and has confirmed 5,200 of them. These are mostly planets that orbit stars other than the Sun, meaning that they are beyond our solar system. Examples are Kepler 186f, Kepler 442b, and Gliese 667 cc. Some of these exoplanets are called rogue planets. They are lone ranges that don't interact with any stars. It's been shown that some of these planets could potentially support life by being in the habitable zone of their stars. If it's habitable, it may as well be inhabited. Astronomists also consider extremophiles on Earth as proof that some planets that seem hostile to life may have some life forms. Extremophiles are microorganisms on Earth that live in insane environmental conditions. Temperatures, pHs, and chemical concentrations that are lethal to many other organisms don't faze these guys. Who says there aren't life forms with similar extreme adaptability in our universe? Missions to Mars, our red planet neighbor, have uncovered evidence that suggests that there may have been liquid water and organic molecules on the planet. It also has seasonal methane variations that may be produced by microorganisms. Because Mars is so close and so similar to Earth, we can't help but wonder what mysterious creatures may have once called it home. What if they still do? No one has heard from our alien neighbors, though, and that's why their existence remains a mystery. Of all the exoplanets NASA has found, none have produced proof of life. We seem to have good leads, but it's still all shrouded in mystery. The seasonal variations in Mars methane levels may be due to geological activities. Besides, most scientists now agree that the presence of habitable conditions does not necessarily prove the existence of life. Well, there you have it, guys. Those are some of the mysteries of our universe that bemuse the generations of humans living on this small blue dot we call Earth. Which one do you find most puzzling? Let us know in the comments.